Welcome to the DIY Honda Garage channel. The DTC P0A11 stands for DC-DC Converter Activation Circuit Malfunction, indicating issues within the DC-DC converter's activation circuit in the Honda CRV models from 2017 to 2022. The DC-DC converter is a critical component in hybrid vehicles, responsible for converting high-voltage direct current, DC, from the hybrid battery to a lower voltage suitable for the vehicle's electrical system. When this circuit malfunctions, it can affect various electrical components and systems, leading to potential vehicle performance issues, such as an inability to run certain electronic features properly. Located close to the power distribution unit under the hood, the DC-DC converter is connected to both the power control module, PCM, and the vehicle's battery. It's essential to address this DTC promptly to avoid further complications that may arise from a malfunctioning converter. The DC-DC converter's primary role is to ensure that the hybrid battery's output voltage is appropriately adjusted to power the vehicle's electrical systems. This component is crucial, especially in hybrid vehicles, as it enables the use of high-voltage battery energy for low-voltage applications. Located near the engine compartment, the DC-DC converter connects with both the high-voltage battery system and the PCM, making it integral to vehicle functionality. When DTC P0A11 is triggered, it suggests that there is a problem with the activation circuit, affecting the converter's ability to perform its duties effectively. This malfunction can lead to various symptoms affecting other electrical components. Understanding the location and function of this component is vital for effective troubleshooting and repair, as any failures in this circuit can lead to significant vehicle performance issues. Several factors could contribute to the DTC P0A11 being triggered. First, there may be an open circuit in the DC-DC STS status line, which interrupts the communication between the DC-DC converter and PCM. This disruption can prevent the converter from activating properly. Another possibility is a faulty DC-DC converter itself, which would fail to operate as expected when called upon. In some cases, issues with the power control module, PCM, which governs the electrical activity within the vehicle, may be at fault. This could include poor connections or a defective PCM. Thoroughly investigating these potential causes is crucial for diagnosing the root issue effectively, as each could lead to failures in providing necessary power to vehicle systems. The symptoms associated with DTC P0A11 can vary, but typically involve failures in the vehicle's electrical systems. Drivers may experience issues such as malfunctioning accessories or inconsistent performance from electrical components, which may not operate correctly when required. Additionally, the vehicle may exhibit warning lights on the dashboard, which act as indicators of problems within the electrical system. These symptoms can escalate if the issue is not addressed, leading to more severe performance problems or even complete electrical outages. It is essential to monitor these signs closely, as they can provide valuable information during the diagnostic and troubleshooting processes for the DTC P0A11. Recognizing these symptoms can lead to faster resolutions and restore functionality to the vehicle's systems. The first troubleshooting step for diagnosing DTC P0A11 involves initial verification of the issue. First, the vehicle should be turned to the on mode, which allows the systems to initialize and prepares for the diagnostics. Following this, it is essential to clear the DTC using the HDS Honda Diagnostic System. Clearing the DTC is a crucial step to ensure that any existing faults are reset, allowing for accurate subsequent readings. After clearing the code, the vehicle must be test-driven under conditions that engage the auto idle stop system to recreate the conditions under which the malfunction may occur. Once the test drive is complete, The next step requires checking for any pending or confirmed DTCs using the HDS. If DTC P0A11 is still indicated, it signifies a genuine problem that needs further investigation. The second step in troubleshooting DTC P0A11 focuses on determining the possible failure area. To initiate this step, ensure the vehicle is turned to the off-lock mode. This mode allows for safe disconnection and checking of the various components without risk of accidental engagement. Following the vehicle being turned off, the next action requires the SCS system check switch line to be jumped using the HDS, keeping it connected for more than 1 minute. This provides a reset state that is crucial for accurate measurements. After the SCS mode is engaged, disconnect the PCM connector A, which consists of 50 pins, and exit the SCS mode using the HDS. This step effectively prepares the system for voltage measurement to confirm the presence of battery voltage at the required test points. At this stage, the focus shifts to checking for an open wire in the DC-DC STS line, which could be a culprit behind the activation circuit malfunction. Start by ensuring the vehicle is turned to the off-lock mode for safety. Next, disconnect the DC-DC converter connector A, which has 3 pins. This disconnection allows for accurate resistance measurement without interference from other components. Then, the resistance between the designated test points must be measured, specifically between the female terminals of the DC-DC connector A, number 2, and the corresponding pin at the PCM connector A, number 14. The goal here is to confirm if the resistance is 1.0 ohm or less, which indicates a sound connection. If the measurement confirms proper resistance, the DC-DC converter must be replaced. Otherwise, proceed to check for any opens in the DC-DC STS wire for further troubleshooting. The fourth troubleshooting step investigates potential shorted wires within the DC-DC STS line that might lead to an activation circuit malfunction. Initially, ensure that the vehicle is turned to the off-lock mode for safety. Then disconnect the DC-DC converter connector A again to prevent false readings during the test. With the connector disconnected, turn the vehicle to the on mode, activating the electrical systems necessary for measurement. The next action is to measure the voltage between the designated test points, specifically between the female terminals of the DC-DC converter connector and the body ground. The voltage should register around 5 volts or more to signify that the system is operating correctly. If this value is confirmed, it indicates a short to power in the DC-DC STS wire, necessitating repairs. However, if the voltage is absent, it suggests the wire is functioning normally, and further action is to substitute with a known good PCM for further diagnosis. After completing the necessary repairs while troubleshooting DTC P0A11, it's essential to perform a final verification of the repairs to ensure all issues have been resolved effectively. Begin by confirming that all repairs have been properly executed, particularly focusing on the connections made to the DC-DC converter and the PCM. Following this, it is crucial to recheck the overall vehicle operation, ensuring that all electrical systems and components are functioning as expected. Once the assessment demonstrates that operations are normal, the next step involves clearing the DTC again using the HDS to ensure that any previous faults are reset and to confirm that the DTC does not reappear during vehicle operation. This final verification process is critical in assuring the long-term resolution of the issue and the reliability of the vehicle's performance. To prevent the recurrence of issues related to DTC P0A11, implementing a comprehensive preventive maintenance schedule is crucial. Regular system checks should be performed on the DC-DC converter and associated wiring to ensure they are functioning properly. During maintenance, inspect all connections and wiring to the DC-DC converter and PCM, looking for signs of wear, corrosion, or damage that could lead to future problems. Additionally, it is vital to monitor the overall performance of the vehicle's electrical systems, particularly after repairs are made, ensuring that all components operate reliably. Keeping track of performance indicators can help catch potential issues early, allowing for timely interventions before they escalate into more significant problems. By establishing a routine maintenance approach, the longevity and reliability of the vehicle's systems will be significantly enhanced. In conclusion, understanding the implications of DTC P0A11 is vital for maintaining the health and performance of Honda CRV models from 2017 to 2022. The DC-DC converter plays a significant role in converting high-voltage energy for use in the vehicle's electrical systems. Thorough troubleshooting, as outlined, ensures accurate identification and resolution of issues, which is critical for long-term reliability. The importance of routine maintenance cannot be overstated, as proactive measures can help prevent the recurrence of activation circuit malfunctions. By consistently monitoring performance and performing regular checks on critical components, vehicle owners can ensure their Honda CRV remains dependable and efficiently operational, minimizing potential disruptions and maximizing driving satisfaction. Please like and subscribe to the channel. See you next time.